Chapter 6, Basic Drawing Tools. This chapter reviews the understanding of the basic drawing tools provided in MicroStation, including placing elements, tool settings, basic workflow, the linear tasks, polygon tasks, arc tasks, ellipse tasks, and undo and redo. MicroStation has dozens of drawing tools, or tools for short. These tools are grouped for convenient selection in toolboxes and are referenced in tasks. Tools referenced in a single task are used to perform a particular task, functionally speaking. For example, the drawing composition task references tools used to compose drawings. Only one task is active at a given time. The tools in the active task are grouped in a special dialog, the tasks dialog. Each open toolbox is either floating in its own window or docked to the edge of an application window. The arrangement of tools in a floating toolbox can be changed by resizing its window. Tools are represented in toolboxes by icons. For simplicity, the term tool is used to refer both to a tool and its icon. Within MicroStation, one tool or another is selected or active at all times. The default selected tool is the Element Selection tool, which is used to select elements for manipulation or modification. When a design file is opened in MicroStation, the Element Selection tool is automatically selected or active. This is the Element Selection tool. This is the Tool Settings dialog. As mentioned earlier in the course, the Tool Settings dialog will change to reflect whatever tool settings are applicable to the particular selected tool. As tools are selected and used within MicroStation, the last tool selected by the user then becomes the default tool. So after you finish using a tool and reset or exit, it'll go back to the last tool you used. FDOT has developed and delivers within the FDOT workspace within MicroStation many discipline-specific tools, toolboxes, tasks, and workflows to assist the user in designing and producing projects to meet FDOT CADD standards. These have been incorporated into the task dialog. As you can see, we do have the FDOT Plans Development task open right now. And just a quick review on navigating the task dialog. Each of these contains tools that are specific to specific tasks, including drawing. So you have most of the drawing tools, if not all the drawing tools, in this one task. So throughout this chapter, we'll be selecting the drawing tools either from here or potentially from the main task, depending. With the main task, you'll notice, these little tiny black arrows that are in the corners of the icons. As you may have seen in previous chapters of this course, pressing and holding will reveal a context menu with the toolbox items. So for example, this is the Modify Classic toolbox, and it contains both the Modify Element tool, which you can access simply by clicking, or the other Modify tools, or of course you can open the Modify task as a toolbar. So in this case, if we're looking at the Linear Elements task, that's right there as a toolbox. So you can take a minute to explore this task and the way the task dialog works. But we're going to go ahead and open up the drawing task. And most of the tools we're using in this chapter come from the drawing task. So a word about placing elements. The objects drawn or placed in a model, lines, polygons, circles, text, etc., are called elements. Each element has several attributes that define the element, as we've mentioned before: the level, color, line weight, line style, fill color for closed elements, class, whether it's primary or construction, transparency, if it's transparent or opaque, or how transparent, and priority, which applies only to 2D elements as really just a display setting. FDOT defines the CADD level symbology standards for level, color, line weight, and line style, as we mentioned before, and it has incorporated these standards in the FDOT tools delivered within the FDOT workspace, so it all works together. The users need only to utilize these tools to create elements set to the required level symbology to pass compliancy with the FDOT CADD standard. So it's all set up for you, ready to go. If you're doing things the right way, it will be compliant. In MicroStation, the left mouse button is mapped to a logical button called the data button, which sends a type of graphic input called data point when pressed. So when you hear me say data point or accept or left click, that means the left mouse button. The right hand button is mapped to the reset button, which is used for resetting and for accessing reset pop-up menu and view control pop-up menu. So here we go. There's a difference with the right mouse button. The right mouse button is the reset button, so if you hear me say reset or exit or get out of, that means right mouse button, and that's just a single click of the right mouse button. However, if you click and hold the right mouse button, a context menu appears here with a number of tools, including the element selection tool, copy, move, and the element information, and a nice little tool here, turn level off by element, which we'll get into a little bit later in the course. Okay, so great. The left mouse button accepts an operation, the right mouse button cancels. So if you're in the middle of drawing with a tool and you decide you don't want to draw with that tool anymore, you can right mouse click to reset or exit that tool. As mentioned before, there's a floating dialog whose title and contents change each time a tool or view control is selected. The dialog is the tool settings window. Almost every MicroStation tool has settings that affect how the tool works and can be controlled in the tool settings window. If closed, the window opens automatically when a tool is selected again. The status bar, as we've talked about earlier, down at the bottom left-hand corner, the status bar displays prompts for how to use the tool. So for example, right now I've selected the Modify Element tool, so it says Modify Element, Identify Element. And then Element Selection, Identify Elements to add to set. So as you see, the tool settings dialog changed, as well as the prompts down in the bottom left. The basic workflow for drawing is the following. Set the active level to select the active element attributes. We did that when we drew a fence in the last exercise. We selected the active level first. Okay? The FDOT CAD standards are based on predetermined bi-level settings, so for FDOT projects, the level attribute need only to be set, and the color, line style, line weight will automatically be set because they're bi-level settings. The step can be skipped if not placing an element or using a tool that does not rely on element attribute selection. So if you're copying, moving, resizing, or modifying or something like that, you don't need to set the active level to perform those tasks. So after we select the active level, I realize we went all off on a tangent there. After we select the active level, you're going to select the tool. So for example, we selected the Place Line tool. You're going to adjust the tool settings if there are any tool settings you want to adjust, and then follow the status bar prompts, which we did in the last exercise. Identify the start of the line, identify the end of the line, identify the end of the line, etc. And I'm going to hit Control-Z to undo because I don't want extraneous lines in my drawing just yet. And you notice that fence line did not look like a fence line, and that's because I still have level overrides on. So I'm going to turn off the level overrides right now. The linear task. Lines are the most basic element in any design file. No matter what discipline is involved, linear elements play a large role in the basic geometry. The Linear Elements Toolbox contains many tools that place linear elements into the design file. You can access the Linear Toolbox by right-clicking here in the Drawing task and select Open Linear as Toolbox. We've got a number of tools, and of course, remember, just like any toolbox, you can right-click on it to turn on and off tools, or see a list of tools by selecting that option. The first tool is the Place Smartline tool. It's used to place a line, line string, shape, arc, or circle, or combination thereof as a complex element. The Place Line tool is used to place or construct a line. The Place Multi-Line tool is used to place a multi-line, which can be made up of up to 16 independently defined lines. Points task is used to place an active point. It is simply a point, a singular point. And you'll notice that this is a toolbox of itself that you can fly out, as is also the Create Curves task. The Create Curves task is used to draw curves and exact isoparametric lines from a solid or B-spline surface. We won't necessarily be covering these three tools very much, as well as the Place Streamline string, which is used to place a streamline string primarily for tracing images when digitizing. I used this some when I traced a bunch of images to create the MUTCD cell library. Place Point or Stream Curve is used to place a curve using the points or stream method. Construct Angle Bisector is used to construct a line that bisects an angle defined by 3 data points. Construct Minimum Distance Line is used to construct a line between two elements at their closest points. And construct line at active angle is used to construct a line that intersects a line or segment of a line, string, or shape at a defined active angle. The one we're going to be focusing on the most is the Place Smartline tool. We already used the Place Line tool. It is, of course, very self-explanatory. You're placing lines. Just click a point and click another point. We will talk about this later on, but every time you see a little yellow X, that's a point you can snap to. So you can draw lines between these points and use that to snap so that it's parallel. And that's something we'll talk about in the Drawing with Precision chapter, which I believe could be the next chapter. I haven't looked ahead in the book just yet. Exercise 6.1 on page 6-6. Open the MicroStation file DSGN RD01, or you might already have that open. It's located in the roadway folder of the dataset DSGN RD01.dgn. Zoom into the location at 206, as location between station 206 and 208. As you recall, we can do this by going Edit, Find Replace Text. Another thing you can do is if you're using the zooming tools, you can marquee zoom in and then use the pan tool, or just use your mouse wheel and move down the road this way. Another option you have is holding down the Shift key and dragging in the direction that you'd like to travel. It's sort of the opposite of the pan tool. But like I said before, easiest way to do it, Edit, Find Replace Text, 206, Find, and it's going to zoom us right in there. There's 206 and 207. Set the active elements attributes from the attributes toolbox located at the top of the application window and change the active level to sidewalk front. Again, we can mouse over the dialog, tap the S, and look for sidewalk front. Our active level is now sidewalk front. Select the Place Line tool. It is located either in the Drawing task or the Linear task. I already have it selected. If I did not have it selected, I could then select the Place Line tool. Okay, great. So I'm on the Place Line tool right here. Notice that the tool settings window is changed. And we're going to adjust the tool settings window instead of actually drawing point to point. I'll show you how you can draw using the tool settings window. So the first thing we're going to do is in the length checkbox, check the length checkbox and enter 200. That's because we know that the line that we draw is going to be 200 feet long. Look at the prompts down the bottom left. It says identify the start. Ignore that window right there, but identify the start of the line. And I believe we're going to be placing sidewalk. And this is the paved shoulder. That's unpaved shoulder. So this looks like a good place to place a sidewalk. We'll place it between 206 and 207. So here's my 200-foot long line. And now it's just asking me to select the angle because we already locked the length at 200. So now it's what angle are we drawing it at? And I'm just going to kind of eyeball that because that's how roadway design is done, right? No amount of precision. After I entered the data point, I hit the reset button to cancel the tool. Let me show you that again real quick. I've still got it locked for 200. I'm selecting the angle, and it's already a 200-foot line, just a 200-foot line. There's no option for, another length adjustment at this point. So I'm entering a data point, and notice the tool continues. It wants to draw another 200-foot line, and I could continue drawing 200 feet lines, but I'm going to hit the right mouse button to reset. And we're going to repeat those steps again with the sidewalk back. And because we've not reached the chapter on drawing with precision, we're not drawing with precision, we are just drawing. I see there's a couple signs here that are going to get in the way of my sidewalk, but that's all right. I'm going to eyeball this again and place a back of sidewalk line. And come down here and kind of say, this looks about the width that I'm going for. And there's some trees right here, so I don't want to put a sidewalk across trees. And there you go. That is a very poorly designed sidewalk, but that demonstrates that you can go ahead and set the length of the line that you're drawing by using the tool settings window. And this comes in a little bit later when we talk about drawing with precision. With AccuDraw, you will be entering numbers for length and angle and Cartesian points. So this gives you an idea that it's not just all about clicking a point here and clicking a point there. You do have control over the length of lines and the positioning of lines in more than just clicking on points on the screen. You can actually enter that data directly into the tool settings window. The Smartline tool works just a little different than the PlaceLine tool. And I want to highlight the difference here. Just drawing out here in space. If I draw, let's go ahead and uncheck the length box. This is not an exercise, this is just a watch thing. So if I draw a series of lines using the PlaceLine tool, you notice they do appear to be connected. But you'll see they are actually very much individual line segments. Right? I'm going to undo that real quick. Hitting Control Z to undo. Alright, and let's look at the Place Smartline tool. With the default settings active, I'm doing exactly the same thing. But you'll notice it's all one line. They are not individual lines. It's all connected. And that's because I had selected the Join Elements. So I'm going to undo that. And I'm going to uncheck Join Elements and draw the same lines. And now you see they are not joined. Well, but does that mean that they're different element types? Well, let's find out. I'm going to undo that. Go back here. I'm drawing Place Line and then Join Elements. And that is a line. And this is a line string. It is not yet a complex chain, and we're going to talk about that later. So it's a line versus a line string. I'm going to delete those two elements. That was another thing that I have not mentioned yet because it's actually not mentioned in this course. But if I have an element and I mouse over it, this is new to V8 iSelect Series 4. Might have been in Select Series 2 as well. But if you select an element and then hover over it, this other abbreviated pop-up menu comes up where you can select the properties. It'll give you a temporary properties dialog. And then there's some civil related tools as well as just delete. So if you want to delete something, you can simply do that. We'll talk more about deleting a little bit later on in this course. We'll draw a bunch of stuff and then we'll delete it. So let's talk about the Polygons task, and then we're going to come back to the Smartline task apparently. Polygons task is right here. It's below the linear task. You can right click and select Open Polygons as toolbox. There's a Polygons task toolbox. And while it is possible to create closed polygonal shapes using the PlaceLine and Place Smartline tools, it is often easier to use the tools contained in the Polygons toolbox. The Polygons toolbox contains tools that facilitate the creation of both regular and irregular polygons. The tools include Place Block, which is used to place a block or rectangular shape. Place Shape, which is used to place a polygonal shape by entering a series of data points to define the vertices. There's Place Orthogonal Shape, which is used to place a non-rectangular shape in which each segment is either perpendicular or parallel to the other segments. And then Place Regular Polygon, which is used to place a regular polygon, one with all sides and angles the same. Real quick demonstration. Place Block does exactly that. It places a rectangle. Notice here's that setting we talked about earlier, solid versus whole. We will get into that shortly. There's the Place Shape tool, and this allows you to sort of place irregular shapes. And here's a neat little thing. It has a Close Element button. That means that when you're done drawing and you have yet to enter your final data point, you can actually just hit Close Element and it's going to draw a line between the first and last point to close that element. Place Orthogonal Shape works this way. Notice it's essentially sort of like Smartline, but it has only perpendicular and parallel angles. And that is an irregular shape drawn with the place orthogonal shape. So the place regular polygon allows you to specify how many edges. So for example, with a hexagon. And there are 3 methods for drawing it. There is inscribed, circumscribed, and by edge. So I could describe these different methods, but I'll go ahead and demonstrate them as I describe them. So the inscribed method, I've already said I want to have 6 edges. You can specify the radius ahead of time in this field, just like we specified the length of that line in the place line tool, or you can enter the data point and then draw the radius. And in the inscribed method, when we go from the radius out, it's the radius to one of the vertices. And you can specify the radius as well as the angle. You can see I'm rotating it. These are things you can actually control using AccuDraw, which we'll discuss later on in this course. So that's the inscribed method. The circumscribed method also comes from the center point, but notice it's the distance from the center to one of the edges as opposed to one of the vertices. And the by edge method allows you to specify the length of one of the edges, and that's how you draw the regular polygon by edge. So if you knew the specific length of the edge, that is the method that you would choose. Now, of course, we can place polygons using the Smartline tool, as I mentioned before. The Place Smartline tool in the Linear Elements toolbox affords more flexibility to place polygonal shapes than the Place Shape tool itself, particularly when used in conjunction with AccuDraw, which we have not learned about just yet. The Place Smartline tool is used to automatically place a complex chain or shape. The difference between the two is a complex chain is not a closed shape. A shape is a closed shape, containing a dynamically specified collection of segments and vertices. Right? This tool is designed to be used in conjunction with AccuDraw. The main benefits of using AccuDraw with Place Smartline are the drawing plane origin automatically moves to the location of a newly defined vertex. Finally, when defining an arc segment, the drawing plane coordinate system automatically switches to polar. So you can see that that's the benefits of using AccuDraw with the Place Smartline tool, and I do want to address that last point. So we're going to talk about AccuDraw a little bit later, but I do want to demonstrate this one point. So if I'm drawing a line, you see AccuDraw as this little compass, and that is the rectangular coordinates configuration. If I switch this to arcs and then enter data point, you'll see it switches to the polar coordinate system. I will point out also, if you're drawing with Smartline and you tap the tilde key or the reverse apostrophe key, which is the key to the left of the number 1 key and above the tab button on your keyboard, it switches from lines to arcs. Notice that little change there? Tap that, lines, now arcs. Lines, arcs. It's a neat little trick. Exercise 6.2, placing an orthogonal shape. Continuing in the same area from the last exercise, which as you recall was 206 to 208, and in the same file, of course, DSG and RDO1, you're going to go ahead and set the active level attributes and select the building level. So just tap B, scroll down, and locate building. Also, let's go ahead and find the specific spot that we're going to build this building, and that's this area right here. So if you're looking at station 206 and 207, we're putting a building right here. I imagine this is like a parking lot or something to that effect. There's a sidewalk, parking lot right there. So we're going to build a building right there. So step 2, from the task dialog, the Polygon Task dialog, select Place Orthogonal Shape. I think really the first thing we should do is rotate this view so that it looks a little bit more easy to work with. So again, snap with the rotate 2 points, 206 and 207. That's a completely unnecessary step, but I like working with everything at a unrotated angle, or at least a relatively unrotated angle. So we're set for building, and we're just going to draw a building. It doesn't specify in the exercise exactly what shape the building needs to be. There's a screen capture in the course guide, but I'm going to start here and draw here. Draw it about like that. Okay, now we're moving this way, and you see it wants to snap to the length that the last line was drawn at, but that doesn't necessarily line up. But since we're stuck at 90-degree angles, all you have to do is snap to this end right here, and that ensures that this line is lined up with that point. And now just come down here and enter one final data point, and your building has been drawn. Now let's do that again. I want to show you the difference between the solid with no fill and the solid with a fill. So I'm hitting Control Z to get rid of this building. I'm switching the setting to opaque. And I'm redrawing this building. And again, indexing over that point, entering a data point, and then closing the shape. And there you are. There's the filled shape. If I were to go to your view attributes and turn off fill, you'd just see the outline. But I'm turning fill on, and of course we have a filled shape right there. Much like the Polygons task, there's also a Circles task for drawing circles. It's a very extensive task. I'm going to open this as a toolbox. It's located right below the polygons on the drawing task. There are multiple methods for each of these tools, and I think the best way to learn these tools is to just experiment with them, to see how these tools work, the different methods of placement. So the circle obviously places a circle, and much like the other tools, you can define solid and fill type and the fill color. The fill color is typically going to be the bi-level color of the level that you're drawing on. And with the circle tool, you can specify the radius or the diameter. Of course, diameter is just 2 times the radius. So let's look at the center method. Well, unsurprisingly, the center method draws from the center of the circle out to the edge, the radius. The edge method is a little strange in that first you draw a line, and then you can decide where that line falls in the circle. And then the final one is the diameter method. We're drawing it from one side of the circle to the other across the diameter. That's the Place Circle tool. Delete those circles because I need the real estate. The next tool on the task is the Place Ellipse tool. It only has 2 options, center and edge, and I'll demonstrate those. Now notice you can specify, just like with the circle you can specify radius, you can specify the primary, secondary, and the rotation of this. Once again, it can be solid, opaque, those characteristics there. So I'm going to go ahead and enter a data point. This is center method. And as you can see, it's asking me to draw a line. It's a little dotted line. And that is the primary diameter of the ellipse. And now I'm drawing the secondary diameter of the ellipse. You see? Watch that again. Primary diameter is this. It's asking you to draw the radius, but it ends up being the diameter. And then you set that secondary right there. The edge method works just like that edge method for the circle, where the edge is the initial primary diameter, but then allows you to sort of specify the angle and the secondary diameter at the same time. Gives you a little bit more of a free-form control over it. I'm not sure how many ellipses you're going to draw in such a freehand way for roadway design, but hey, those tools are available to you. So check those out, experiment with it, get a feel for those 2 methods. It gets even more ridiculous with the Place Arc tool because you do have 4 ways to place an arc. The start and center point, the center point and then the start, the middle, and the end, and the start and the end in the middle. I'm going to sequentially demonstrate. Start center is data point. You see we're specifying the radius of the arc first, and then the length of the arc. So it's a starting point to the center, specify the radius, and then it allows you to set the angle of the arc. Center start works the other way. We're moving out from the center to the radius, the edge, and then doing the same thing, setting the angle there. Start, middle, end is the outside to the middle of the arc itself. And you see it has this line here that sort of functions a little bit like that edge method for drawing the circle. It gives you a lot of control there. And you see this point right here, little x is the center of the arc. Then start, end, middle. Starting point, end point, and it allows you to draw up from that central point. So those are some of the circular tasks. There are more circular tasks, and of course you do have the option to modify the arc angle, modify arc axis, and modify arc radius. So here we are, we can modify the arc that we already placed. We can modify the angle of the arc, and that stays on the same diameter or radius of that arc as we edit it. And then modifying the arc axis, you can kind of modify that. A lot of different tools. The best way to learn the circles task is just to get in there and try out the tools. But now you've seen them demonstrating, you see what they do. And the best thing about the basic drawing tools is the end of the chapter, which is the undo and redo tools. You saw me undoing what I had done by hitting Control Z. Just like any Windows program, Control R redoes the things that I undid. So whereas most Windows programs, it's Control Z and Control Shift Z to undo and redo. In MicroStation, it's Control Z to undo and Control R to redo. You do have the option to come up here and undo. It does tell you what the last task you did was. You can undo to a specific mark, which you can set, because of course your MicroStation files have a rather robust undo history. So undo, redo, set mark, undo to mark, and undo all. If you do undo all undoes everything that was done in the current work session since the last time you compressed. So if you've been working on a file for 3 days and you haven't compressed it at all and you do undo all, it'll undo everything that you've done. So that is Chapter 6, Basic Drawing Tools. Chapter 7, we're moving on to Drawing with Precision.